Hey guys, welcome back to another lesson. Today we are going to be continuing talking about line segment relationships in circles, and specifically we are going to be talking about the secant segment. So recall, a secant is a line that intersects with a circle at 2 points and extends beyond the circle. So specifically what you need to focus on is when you talk about secants, there is an outside part that is outside of the circle. There is an inside part that's inside the circle. So the red and green parts are the outside parts. The purple and blue parts are the inside parts. And then there's the whole secant, which has a vertex at the angle. So that's the end of that red portion that's outside of the circle. And then the other end is on the other side. So if I look here, I've got this point right here. That's the whole secant, right? For secant 1. And then secant 2 has one of the same endpoints, and then the other one is over here. All right. So the relationship for secants is you take the outside part times the whole thing. So let's go through some examples and see what this looks like, all right? So first, if I look, well, I'm going to take a look at that top secant. So what's outside of the circle is 4. 4 is the red part. So 4 is the outside part times the whole part. I would do 4 plus the inside part. So 3.5. I do outside plus inside. And that has to be equal to, let me see, I don't have enough space, so I'm going to move my work down. Okay, so we've got, boop. Okay, then for my second secant, I've got my outside part is 3 times the whole is outside plus inside. So 3 plus x. Okay, so now let's see here. On the left hand, and now I'm just going to solve this algebraically. So I can simplify inside the parentheses. 4 plus 3.5 is 7.5. So 4 times 7.5 is equal to, now in the second one, I can't simplify inside the parentheses, so I'm going to distribute. So 3 times 3 is 9, 3 times x is 3x, so 9 plus 3x. In my next step, I'm going to do 4 times 7.5, sweet, so I get 30. 30 is equal to 9 plus 3x. Subtract the 9, 21 is equal to 3x. X is equal to, whoa, what happened there? Oh my gosh, it's a disaster. Just kidding. It's fine. So x is equal to 7. That is my final answer here. Glorious. Okay. See, I got this. See, when I see secant relationship, I see can. I can do this. See, I can. I hope you found that funny. Next, level 2. So we're still going to do outside times whole. Outside part times the whole part. So in this case, in the line on top, my first secant, I've got 6 is the outside part. And then my inside part for inside the parentheses, that's already given to me. That's 15. So 6 times 15 is equal to 5 is the outside part of the second one times 5 outside plus x inside. Gives me the whole. So 6 times 5 should be mental math. Is that 90? 6 times 15? Yeah, it is 90. Okay, so 90 is equal to, once again, distribute 25 plus 5x, subtract 25 from both sides. 65 is equal to 5x. 13, is that my guess? 65, yeah, x is equal to 13. Okay, so far so good. So it's always just outside times whole. All right, sometimes you need to add to find the whole, sometimes you don't. That's fine. Okay, so this one's a little bit different. So if I look at that top secant, the red and purple one, I don't actually know what that outside part is, right? The full length is 12. So in order to get that length, I actually need to do some work first. Ooh, what happened here? Okay, I am going to take 12 the whole minus 6, the inside part, to get my outside part, which is 6. Okay, it's not always going to be the same, so make a mental note of that. So now, problem number 3, I'm going to do my first secant. 6 is the outside part, times the whole is 12, equals 4, the outside part, times the whole will be 4 plus x. Okay, so 6 times 12 is 72, equals, distribute, for 16, 4 times 4 is 16, plus 4x. 72 minus 16 is 56, is equal to 4x. Divided by 4 is 14. X is equal to 14. Okay, so you guys are champs. So far, so good. Yes. Let's see if we can kick this up a notch. So this one is different. When you see the variable on the outside part, that creates a little bit of a different situation. Why, you ask? Well, let's find out. Let's set up our equation. Okay, so the first secant, red and purple, x times x plus 5 is equal to 3 times 3 plus 9. Okay, so far so good. I'm doing outside times whole, right? Outside times outside plus inside, which gives me whole. Sweet, got it. So let's see what I need to do here. Now let's start to simplify. Well, notice as you distribute, you get x squared. Interesting. X squared plus 5x is equal to, well, let me see here. This one I'm going to actually simplify in the inside first. So that's equal to 3 times 12. So x squared plus 5x is equal to 36. Remember, this is kind of a throwback. We've done some practice with factoring, and you guys definitely did it last year in algebra. To factor this, because I've got x squared, it's a quadratic, I need to factor. I need to get everything equal to 0. So I'm going to subtract the 36 from both sides. So I get x squared plus 5x minus 36 is equal to 0. Okay. So now you guys recall, we've talked about this before. We make our little x. Boop, 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 boop. Oopsies. I'm not going to do that, actually. Uh-oh, what's going on here? We make our little x, their dashed line, and then the it's like an imaginary 1 out here, right? So 1 times negative 36 is negative 36. That goes at the top. The positive 5 goes at the bottom. I need two numbers that multiply to a negative 36 and add to a positive 5. Multiply to a negative, add to a positive. One needs to be positive, one needs to be negative. And my answer is positive. So I'm going to say a positive 9 and a negative 4. Since my leading coefficient is 1, I divide by 1, so equals 9. Divide by 1 equals negative 4. So those give me my two factors. My two factors of this are x plus 9 times x minus 4. And that is equal to 0. So why did I need to factor? Because now I can say x plus 9 is equal to 0, and subtracting the 9, x is equal to negative 9. Or I can say x minus 4 is equal to 0, and adding the 4, x is equal to 4. So these are my two possibilities for x. All right, so there's kind of a lot in this whole process. Let's recap. Right? I set up my equation by using the secant-secant relationship. I distributed and simplified. Okay, continued to do that. Then I got I got everything to equal 0 because I saw that I have a quadratic and I need to factor. I factored my quadratic and I set each of those terms equal to 0. Well, x in terms of the situation, x is the length of a side. So now I've got these two possibilities for what x could be. X could be equal to negative 9 or x could be equal to 4, but I am talking about a side length. So I am going to say, no way is it equal to negative 9. Side lengths cannot be negative. So my final answer for this problem is 4 because that is the positive side length. So in problems like this, when you're talking about side lengths, you select the positive. All right. And some of you folks at home who are watching this are like, oh my God, Miss Leverson, it has been so long since I have factored. I don't even remember how to do this. That's fine. Make a note. This right here is it's a little bit of an extension, right? So if you really don't remember how to factor, do not panic about that. It's okay. Just your main concern for this lesson is that you get solving the other problems 1 through 3. All right. This last one was just a little bit of an extension. As always, if you have any questions, feel free to email me. Otherwise, have a great day, Nikolai.